When volcanoes erupt, they produce hazards that can be destructive and deadly. Lava and pyroclastic flows, lahars, yokohobs, and landslides all affect the blast zone. Usually the area within around 10 kilometers of the volcano. But the ash released from volcanoes can be transported by the wind over distances of hundreds to thousands of kilometers. So what are the impacts of this volcanic ash on environments and ecosystems? And how can investigating past eruptions help us understand future risks for people and the environment? To find out, I spoke to Dr. Joanne Egan, a geographer who explores the impacts of volcanic eruptions that occurred thousands of years ago. Let's begin by hearing from Joanne on the importance of investigating volcanic ash.
We can look at what's happening right next to a volcano, which would be kind of the proximal impacts where you do get your lahars and pyroclastic flows. And that's going to obviously kill everything around it. But the further you go away, we start to question, well, what is the actual impact? And that's where the volcanic ash will become more important. So if you look at the more distal locations, which might be hundreds of kilometres away, then what we'll actually find is that the impacts can be quite variable on different environments. So understanding just how far some of these impacts can be felt, then I can start to understand what's actually potentially going to be the environmental impact of volcanic eruptions in the future as well.
Joanne's current research focuses on the eruption of Mount Mozama 7,600 years ago, one of the largest eruptions in North America in the past 10,000 years. Back to Joanne, describing the extent of the volcanic ash released from this eruption.
Mount Mozama is now known as Crater Lake, which is based in Oregon. And when that erupted, it released a huge amount of volcanic ash, which is also known as tephra. That volcanic ash deposited over a really extensive area of North America. It kind of blew its way over in a northeasterly direction, and it covered much of the Pacific Northwest of North America, but we've also found some volcanic ash as far as Newfoundland in Canada, and it's also been found in the Greenland ice cores as well. So it's been a really, really extensive volcanic deposit.
As winds transported volcanic ash hundreds of kilometers from the site of the eruption, it disrupted terrestrial ecosystems, including the forests of North America.
I did my research in a forest area within Washington State, which is about 500 kilometers away from Crater Lake. So it's a distance away from it. It's not anywhere nearby. Nobody around Washington State would have known that that volcanic eruption had happened, apart from a little bit of ash that was falling. And that ash deposit, it varies in thickness, but around the area that I was looking at, it was about 5 centimeters thick. So, it's not a huge amount, probably about that much. But that is enough to actually bury some vegetation, so it would kill off all of the grasses because it would bury it. It would stop photosynthesis happening for those species. But then even for some tree species, what would happen is the volcanic ash would sit on the leaves, and if it was raining, which is often quite common after you've had volcanic eruptions, is it would cause like a cement on the leaves, and that would stop any gas exchanges happening. So again, it would stop photosynthesis and it would block the stomata. So it would actually prevent growth of some vegetation and potentially kill some vegetation as well.
The wide-spreading ash also altered the chemistry of lakes and disturbed aquatic ecosystems.
The volcanic ash, it can introduce lots of new nutrients into the lake, which might be really great for some species. Some vegetation might thrive with those new nutrients. But it also might be too much for some species, so you may see a complete change in dynamics in that area. And what we also may find is that because the volcanic ash sometimes is quite acidic, all of a sudden you've got acidification of the lake, which can actually kill quite a lot of species off as well.
Mount Mozama had huge consequences for forest and lake environments over 7,000 years ago. So how can all this research be used to understand the future risks to people and the environment?
So we'd have to think about, well, if we have a huge amount of volcanic ash that's deposited, is that going to potentially impact various agricultural settings? So thinking about crops, if you have 10 centimetres worth of volcanic ash, that could potentially just kill off all of the crops, which would have economic problems, but then also it could lead to problems in terms of food security. But even when we think about water security as well, you know, we do rely on fresh water bodies for water resources and drinking water, and in some locations that water is going to be much less available than in other locations, like the Mediterranean, for example. They are sometimes restricted in their water. So if all of a sudden you've then got a volcanic eruption that's deposited a whole amount of volcanic ash in some of their water supplies, then that becomes a problem and they have to somehow treat that water. So thinking about food security and water security in particular, understanding how the volcanic eruptions in the past have potentially had those impacts will be really important, but then also thinking about the environment as well.
"7,600 years ago, volcanic ash from the eruption of Mount Mozama spread from the west coast of North America all the way east to Greenland. Thick ash settled on woodlands, killing grasses and preventing the growth of vegetation, and in rivers and lakes, causing acidification and changing aquatic ecosystems. Were an eruption like this to occur today, it could create huge challenges for food and water security, killing crops and contaminating reservoir supplies. Studying examples of past eruptions like this provides curious geographers with powerful insights into the wide-reaching impacts of volcanoes. It is only with this understanding that we are able to prepare for and manage the environmental and social impacts of future catastrophic eruptions.